In this video we're going to look at maximum and minimum turning points. Another name for it is stationary points. Okay, I'm just going to point at this graph and I'll show you where its maximum and minimum points are. Its maximum point is here, its minimum point is here. Now I'm going to ask you a question about those points. What do you think the slope of the tangent to that graph at those points are? I'll draw the tangents to the graph at those points. There's one. There's the other. Now, what can you say about the slopes of those tangents? Well, the slope equals 0. So, at any maximum or minimum turning points, the slope of the tangent to the graph at those points is 0. So, in order for us to find the maximum or minimum turning points, I will differentiate the function. I'll let it equal 0 because that's the slope, and then I'll work back and I'll find the value that will give me the slope of the value that I can put in to get 0. Okay, it'll make more sense as I go through. This question here, that has a maximum and a minimum value. Alright, so when I differentiate that function, when I let the differentiated function equal 0, and when I work back to find out my x value, I will get two values. One will be a maximum value, or one will be where the curve is at its maximum. The other will be where its curve is at its minimum. Okay? However, something like this, that just has one value. So it'll either spit me out a maximum turning point if it was a curve like this. However, if it was a curve like that, well, then it would be spitting out the minimum value. Alright? Just to go back on that again. Okay, let's take this one. I have my curve. I want to find its maximum and minimum values. If I look down here, I'll differentiate the function. Then I'll let the function equal 0. And then I'll work back and solve to see what x value gives me 0. And let's just say it was x equals 1 and x equals 5. What that would mean is, if I go back here, x equals 1, x equals 5, that would mean that where x equals 1 is the one turning point, and where x equals 5 is the other turning point. Okay? It doesn't tell us though which one is the maximum and which one is the minimum. Only the x value where each can be found. Okay? Right. Let's look at this question then. It says find the turning point of 3x squared minus 12x plus 4 equals 0. If I was just to sketch that, alright, just think, what shape is it? Well, x squared, so it's quadratic. Is it going to be an N shape or a U shape? Well, it's a plus value here, so it's going to be a U shape. So this is going to have a minimum value. Okay? Right. So how do I find where that minimum value is on the x-axis? Differentiate it. So dy dx equals 6x minus 12. Let that equal 0. So look, I'm after differentiating it. Now I let it equal 0. And now I have to solve it. So 6x minus 12 equals 0. So 6x equals 12. So x equals 2. So what they're saying there is, on this graph, the minimum value there, okay, on the turning point, is at x equals 2. So if that's 1, that's 2. Okay? Now they're asking here, is this a maximum or minimum turning point? Well, before I even show you the exercise that we can do to find that out, intuition would tell us that it's a minimum point because we know the shape of the graph. So it has to be a minimum point, alright? But there is another way of finding it out. Okay, let's look at this. It says find the maximum turning point of this. X cubed, say y equals x cubed plus 6x squared plus 9x minus 7. So the first thing I have to do, anything to do with maximum or minimum turning points or stationary points, I'll differentiate. I'll get dy dx equals 3x squared plus 12x plus 9 equals 0. So differentiate, let equal 0, that's what I've done there, and solve this. So I want to solve for x. I can divide across by 3 actually to make it easier. Okay, so if I factorize this, x, 3, 1, plus, split it, x plus 1 equals 0, x plus 3 equals 0. That means x equals minus 1, and x equals minus 3. Okay, but it says find the maximum turning point. But I have two values. So I need to find out which one is the maximum. I know one of these is the maximum and the other one is the minimum, but I don't know which is which. So we come back to that. Okay, now look at this, right? We come back to that question. I want to just go to this first. When we're determining the nature of a turning point, what I mean by determining the nature is seeing whether it is a maximum or a minimum value. Well, what we do is I'll differentiate the function twice. So look, I have my d squared y over dx squared. So I differentiate it twice. I'll put in then the x value. If the answer I get is less than 0, then it's a maximum turning point. Okay? Remember that if it's less than 0, it's maximum. You might be thinking if it's more than 0, it's maximum. No, if it's less than 0, it's maximum. If it's more than 0, it's minimum. Okay? And I would have spent a little while in class showing you why that is. Like why when it's less than 0, it's the maximum turning point, and when it's more than 0, it's the minimum turning point. Okay, but I won't get into it here. Right. So what I mean by that is, let's look at this function. And they're telling us it's turning points at x equals 5 and at x equals 1. So they're telling us already. But they want us to find the nature of these turning points. They want us to find out which one is maximum and which one is minimum. Well, what I said is, we have to differentiate it twice. We have to get the d squared y over dx squared. So differentiate it twice. Well, if I differentiate it once, so dy dx equals 3x squared minus 18x plus 15. Now differentiate it again. D squared y over dx squared, and I will get 6x minus 18. Okay, so I'm after differentiating it twice, so I'm after doing this bit. Now I need to check my 2 points. So I'll check x equals 5, okay, this one here. Okay, so this x equals 5, check that. So put 5 in for x. So we have 6x minus 18. So 6x minus 18. So 6 5s minus 18. 6 5s are 30 minus 18, which will give me 12. Now, 12 is greater than 0. So look back up here. We're looking for which is greater than 0. So look, greater than 0. If my differentiated function, my differentiated twice function is greater than 0, then that's a minimum height. So at x equals 5 is minimum height. It goes without saying then that at x equals 1 we have a maximum height. Okay. Okay. So going back to this question, we have 2 turning points. I want to find out which is the maximum, because I'm looking for maximum turning point. So what I have to do is take this function y equals x cubed plus 6x squared plus 9x minus 7, and I need to differentiate it twice. I'm already after differentiating it once. I got 3x squared plus 12x plus 9. So that's dy dx. I need now to differentiate it a second time. If I do that, I will get 6x plus 12. Now I want to find out which of these points, this one or this one, is the maximum point. Obviously the other one is the minimum point. So take my new function, the 6x plus 12, and I'll try minus 1. So I'll put minus 1 in there. So 6 multiplied by minus 1 is minus 6 plus 12, which will give me 6. 6, so I'll do it over here, 6 is greater than 0. If we go on to this next page, so when it's greater than 0, it's the minimum point. We don't want that, we wanted the maximum point. So, don't want that, that's the minimum point. So obviously then, the x minus 3 will be the maximum point, but let's just make sure. Take our function, 6x plus 12, put in the minus 3, 6 minus 3 plus 12. 6 minus 3 is minus 18 plus 12, and that's minus 6. Minus 6 is less than 0. When it's less than 0, it's the maximum. Okay, we're not done though. Have a look up. They want the maximum turning point. We're after giving them the x value of that turning point. So if I was to sketch it, okay, so what was it? Max turning point minus 3. So watch now. Something like that. Let's say there was our max turning point. We found that that was at when x is minus, when x equals minus 3. However, that's not giving us the point. That's only giving us the x value, minus 3. How do I get the y bit? Well, what we do, we take our minus 3, we go back to the original function, we put minus 3 in for x. Okay, so let's do that here. This will give us our y value. So y equals minus 3 cubed plus 6 minus 3 squared plus 9 minus 3 minus 7 equals 0. That will give us y equals minus 27 plus, well, we have 3 squared is 9 multiplied by 6, which is 4, minus 7 minus 7. So get rid of that 0. Y equals, well, and that will give us, well, they'll cancel, the minus 27 and minus 27 is 54, so we'll be left with minus 7. So y is 27. So the maximum point here is minus 3 minus 7. So in fact I'll have to re-sketch this. It'll probably look something like this. So the maximum point is at minus 3, I know that. Okay, so the maximum point is down here. The minimum point will be further down. Right, if you wanted to find out the minimum point, you could just take the x equals minus 1 and do the exact same. Put the minus 1 in there and it would spit you out an answer. Okay? Right. So I'll do a full question then. I'll do a few questions and hopefully that will be enough for you. So find the turning points of the curve y equals x cubed minus 9x squared plus 15x and determine the nature of these turning points. Right, so the first thing we do is we'll differentiate it, let equal 0 and solve for x. So dy dx equals 3x minus 18x plus 15. Let it equal 0 and solve for x. I can divide across by 3 actually, so I get x squared, so x squared minus 6x plus 5 equals 0. I can factorize that, there's no need to use the minus b formula. Okay, so just to make sure that's right, x by x, x squared, minus 1 plus minus 5, minus 6, and minus 1 multiplied by minus 5 is plus 5. Let both equal 0. For x equals 1 and x equals 5. So I know now I have two turning points at x equals 1 and at x equals minus 5. I want to determine the nature of these turning points. Okay. Now remember, I just have the values. Okay, I don't have the points yet. I have the values. So here, sure, why not? Let's get the points first, right? I have the values x equals 1 and x equals 5. So I'm going to put in x equals 1 into the function to get the y value. So we have x cubed minus 9x squared plus 15x. If we put 1 into that, so x cubed, which is 1 cubed, minus 9, 1 squared, plus 15, 1. This will give us out 7. So y equals 7. So one of the points, I'll write it up here, is 1, 7. I'll redo that, but this time I'll put in 5 for x. And that will spit me out minus 25. So my other point then is 5 minus 25. Okay. Now, I suppose, just looking at those points, okay, looking at this one and this one. By looking at that, you could tell me which the maximum point is and the minimum point. Just have a look at the y value. The y value here is 7, the y value here is minus 25. Whichever the biggest y value is, that's obviously the maximum point. Okay, so if you look here, that maximum point there will be 1, 7. That minimum point there will be 5 minus 25. Okay, so that is another way of doing it, right? Just having a look at the 2 points and seeing which y value is biggest. So straight away I can say that actually that is the maximum and that is the minimum. Alright, but let's just do it the other way. Okay, let's find out the other way. So, I've differentiated once, which I got 3x squared minus 18x plus 15. Differentiate again, and I get 6x minus 18. Take my x equals 1 and put it in x equals 1. So that'll be 6 1s minus 18. 6 minus 18 is minus 12. Minus 12 is less than 0. So therefore, that is our maximum value. And likewise, if I put in 5 for the x, now we get 12, and 12 is greater than 0, so it's the minimum, which I suppose just reiterates what we said up here.